Today we will going to discuss Cauchy-Reiman equation in polar form. A complex number z is given by x plus I(y). The relations between Cartesian coordinate and polar coordinate is given by x equal to r cos theta, y equal to r sin theta. We have already discussed this in the polar representation of complex number, so that if you square both the equation and add it, we will add the left side with left side and right hand side with right hand side. This will be x square plus y square equal to r square within bracket cos square plus theta, cos square theta plus sin square theta, which is 1. So ultimately we will get r square. Put this equation 1 and divide this equation by this, you will get tan theta, r cancel out, and in the right hand side you will get y by x, so that theta is equal to tan inverse y by x. So this is equation 2. Now differentiating 1 and 2 partially with respect to x and y, we get if I differentiate this equation 1 partially with respect to x, then I will get here 2x. Here y square will be constant because I am differentiating 1 with respect to x partially, so treating y as constant. So in the right hand side it will be r is a function of xy, so this is 2r, where I am differentiating r partially with respect to x, so that I will get del r by del x is equal to x by r. Similarly, differentiating this equation with respect to y, I will get here 2y equal to 2r del r by del y. So here del r by del y is equal to y by r, and here x by r is my cos theta. Here del r by del y is sin theta. Next, differentiate 2 with respect to x and y partially, that is del theta by del x will be first differentiation of tan function, then differentiation of this function. This will give you del theta by del x is equal to 1 plus y by x whole square, then differentiation of this function treating y as constant, so this will be y by x square. This is minus y, so this is x square plus y square by x square. This is 1 by x square. I have taken the LCM. This is y square by x square. I have taken LCM, then multiply this by x square. I will get this one. This cancel out. I have left with minus y by x square plus y square. Minus y is my minus r sin theta, and this is r square. This r cancel out, minus sin theta. That is del theta by del x is minus sin theta by r. Again, del theta by del y will be differentiation of 2 with respect to y treating x as constant. That is, this in the left hand side, this is del theta by del y. Here it is the differentiation of tan function, then differentiation of this function. So write it. This is 1 by 1 plus y by x whole square dot, this is differentiation of this function with respect to y treating x as constant. This is constant. Differentiation of y is 1. So this is x square plus y square by x square. So 1 by x. This is equal to x. This x will come to the numerator, and this is x square plus y square. And this is your r cos theta divided by r square. And this is cos theta by r. That is del theta by del y is equal to cos theta by r. Next, a function of complex variable is represented by w equal to fz, and it is denoted by u plus, which is equal to u plus iv, where u is my function of uxy and v is a function of bxy. 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 X comma y equal to r comma theta. Now find out the partial differentiation of del u with respect to x. Since u is my function of x and x is function of r theta, so del u by del x will be equal to del u by del r and del r by del x plus del u by del theta by del x. Now put the value of del r by del x and del theta by del x. It is cos theta del u by del r, and this is minus sin theta by r del u by del theta. Let me check whether we have put the correct value of del r by del x or del theta by del x. Del theta by del x is minus sin theta, so this is minus sin theta, and this is cos theta. Next is del u by del y. Everything will be same, only x is replaced by y, because u is a function of xy and xy is a function of r theta. Okay, everything will be same, only the variable x is replaced by y. This is now sin theta del u by del r, then this is plus cos theta by r del u by del theta. Is it okay? Del theta by del y is cos theta by r, so del r by del y is sin theta. Again, del v by del x, which is equal to del v by del r by del x. Del v is a function of xy is a function of r theta. Del v by del theta by del x. So del r by del x will be my cos theta. Del v by del r, del theta by del x will be my minus sin theta by r del v by del theta. Now del v by del y equal to del v by del r by del y plus del v by del theta by del y. This is my sin theta del v by del r plus cos theta by r del v by del theta. Let me check what is the value of del theta by del y. That is cos theta by r. Okay, this will be del r by del y will be sin theta. we know we know we know that Cauchy-Reiman equation Cauchy-Reiman equation Cauchy-Reiman equation Cauchy-Reiman equation in Cartesian form is form is del u by del x by del b by del y and minus del u by del y equal to del b by del x. I am putting this minus here. Now next substituting the value of partial derivative, the value of del u del x, del u del y, del v del x, and del v del y in the Cauchy-Reiman equation. Riemann equation, we get what we get? Del u by del x. Del u by del x is cos theta del u del r minus sin theta by r del u del theta. Cos theta del u del r minus sin theta by r del u by del theta. Del u by del theta. Del u by del theta. Is it okay? Cos theta minus sin theta. Okay. Then del v del y. Del v del y is sin theta del v del r cos theta. Sin theta del v del r cos theta by r. This is plus del v del theta. Is it okay? Yeah. Put this equation 3. Again, second equation of CR equation. Next, del u del y. Del u del y will be sin theta del u del r plus cos theta by r del u del theta. Sin theta del u del r plus cos theta by r del u del theta. Is it okay? Sin theta del. Next is minus. Put minus, then put bracket. Del v del x. Del v del x is cos theta del v del r minus sin theta by r del v del theta. Cos theta del v del r minus sin theta by r del v del theta. This is 4. Next, multiply 3 by cos theta and 4 by sin theta, then add both the equation. What we will get? Add this. If I multiply this by cos square theta del u del r, then this is cos theta sin theta by r del u del theta. This is equal to here. This is cos theta sin theta del u del r. Then this is cos square theta del v by del theta by r square. Again, this is r square. Again, multiply this by sin theta that is sine square theta, del u del r. Then this plus sine theta cos theta by r del u del theta equal to minus, expand the minus, here it is sine theta cos theta del u del r. Minus minus will be plus, sine square theta by r. There is no r square here. There is no r square. There is no r square. This is del v by del theta. Now add these equations. Left hand side will be added to left hand side. Right hand side will be added to right hand side. This will be cancelled. This will be cancelled. This will be cancelled. Take del u del r common. Within bracket it will be cos square theta plus sine square theta del u del r. Then it will be take 1 by r common. Within bracket it will be cos square theta plus sine square theta del v del theta. So this is 1 and this is 1. So this is my del u by del r equal to 1 by r del v by del theta. So in next step, this is del u by del r, that is 1 by r del v by del theta. So this is one of the CR equation in polar form. So put this equation 5. Next again, multiply 3 by sine theta, subtract and 4 by cos theta and subtract it. Multiply 3 by cos theta, subtract and 4 with sine theta. Then it is cos theta. This time it is sine theta, not cos theta. Sine theta. Then it is cos theta. Multiply 3, equation 3 by sine theta and 4 by cos theta and subtract 4 from the resulting equation. We will get, when we multiply 3 with sine theta, it is cos theta sine theta del u del r. Cos theta sine theta del u del r minus sine square theta by r, del u del theta, which is equal to, this time it is sine square theta del r del v, sine square theta del v del r plus sine theta cos theta del v del theta. Next, multiply this cos theta sine theta del u del r. Then again plus cos square theta plus cos square theta by r del u del theta is equal to minus cos square theta del v del theta minus cos square theta del v by del r. Minus will be plus, then sine theta cos theta, sine theta cos theta by r plus sine theta cos theta by r del v del theta. Let me check whether there is r or not here. There is one r here. This r. This r. I forgot to write this r here. If we multiply this equation by sine theta, then it will be sine theta cos theta by r del v del theta. So right here r. Now subtract both this equation. Subtract both this equation. This will be minus, this is again minus. This is plus, this is minus. So this cancel with this one. This will be take minus common. Then 1 by r, 1 by r. Then sine square theta, sine square theta plus cos square theta. Then del u del theta. Again this minus cancel with this plus, so here minus minus will be plus. This is sine square theta, sine square theta plus cos square theta. Take del v by del r is common, del v by del r common. Del v by del r common. This is 1 and this is 1, this is minus 1 by r del u by del theta and del v by del r. Minus 1 by r del u by del theta del v by del r. See? Put this equation 6. This equation 6. Equation 5 and 6 are the Cauchy-Reiman equation in polar form. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.